example, they may ask how they will ask the questions on quantum numbers. They may ask the question, write the 4 quantum numbers. Write 4 quantum numbers for 3s1. Like this they may ask the question, or otherwise they will give the 4 options which is correct 4 set of quantum numbers for 3s1. Right, 3s1, first electron, only one electron is there, obviously 3s1. Here what is the number is there? That is n value, means principal quantum number value n is equals to 3. And this is s orbital. S orbital means you know that L value is n is equals to 3. For s orbital, L equal to 0. Okay. If L equal to 0, m value is, if L equal to 0, m value also 0. We know that, right? For s orbital. Now only we have written. Means m value means we can write s orbital like this. How many electrons are there? 1 electron. First electron is in clockwise direction. It can, we know that, do you know, s orbital can accommodate, means each box 2 electrons mark. S orbital can accommodate 2 electrons. S orbital can accommodate 2 electrons. This is a p orbital. P orbital can accommodate how many electrons? Yes, correct, 6 electrons. D orbital can accommodate 5 boxes are there. We should not call as boxes, but for our convenience, 10 electrons. F orbital, right, correct. F orbital, 14 electrons. 14 electrons. Now, within that, s orbital can accommodate 2 electrons, but they given only 1 electron. First electron always clockwise direction, means after filling in clockwise, then only you need to write like this. So, it is up hook arrow, s value is plus of. I hope you understand how to write quantum numbers per electron. One more example I am going to give. 4p4, fourth electron. For fourth electron, you need to write the what? Quantum numbers. Obviously, n here what is the number is there? That is not this number, 4. So fourth shell. Okay. L value for p orbital. For p orbital, L value S0, P1, right. And m value may be -1, 0, +1, right. Means you need to write this one. Right. First electron, second electron, third electron, fourth electron. Why, ma'am? You can write like this, no? First electron, second electron, third electron, fourth electron. We should not write like this. So that is one more rule is there. That rule also we will discuss later. So first half fill we need to do, then only fulfill. When we are doing the half fill, that should be in clockwise direction. After that, anti-clockwise direction. Are you clear? I hope you understand. Right. Now we are going to know about the fourth electrons. So fourth electron, this is a fourth electron. Fourth electron is having m value is -1. M value is -1, right. Spin value, is it a clockwise or anti-clockwise? Clockwise or anti-clockwise? Anti-clockwise. So -12. So -12. Do you understand? Right. One more example. This you need to do. 5d7. Fifth electron I want. Fifth electron. That is my wish. Whatever electron I want, I can ask. Fifth electron. If they are not asking any electron, means seventh electron you need to do. Fifth electron. Right. So Pi means n is equals to pi, right? L is equals to per d orbital 0, 1, 2, 2. Okay. For next m, m means d orbital 5, no, 5 suborbitals are there. So minus 2, minus 1, 0, 1, 2. Why minus 2, 2 plus 2? Because m value is minus L2 plus L. This one. We want for fifth electron. Where is the fifth electron? First electron, second electron, third electron, fourth electron, fifth electron. This one. We don't want all these. M is equals to 2. I hope you understand. Yes, spin quantum number is at clockwise direction, anti up arrow, so plus half. So plus half. Now, this is example they given. By using these values, you need to write the orbital 3. So 3 orbital. 3 orbital, 3 shell, right? L value 2. L value 2 means for which one? P orbital, right? Huh? P 0, 1, 2, D orbital, right? D orbital. D means this one. This is D orbital. D orbital plus 1 is having for fourth electron, right? This is D orbital, ma. Where m they given as a plus 1, so plus 1 is for D orbital, and for fourth electron, sixth electron, seventh electron, eighth electron, ninth electron, 10th electron. Means fourth and 1, 2, 3, 4, 5, 6, 7, 8, 9, 9th electron. Both are having plus 1 value only. Okay. Based on spin, you can find out. For spin, this is plus half, this is minus half. Now, which electron? Fourth electron. So, 3d4. 3d4. I hope you understand. Based on n value, we have written 3. After that, L value, D orbital. M value, S value is using to find out what is the particular electron. Based on these two values, we can find out a third shell D orbital. Up to that, we can find out by using. If you want to find out the particular electron, where it is, in which direction it is, you need to use magnetic and spin quantum number. Magnetic and spin quantum number. So, if you take a D orbital means 5 suborbitals are there. M value they given as a plus 1. So, plus 1 orbital we are taking plus 1. Plus 1 is for 2 electrons it is there, 4th electron and 9th electron, by using the spin quantum number. If they given spin is minus half, then it is 3d9. Then it is 3d9. I hope you understand, right? After that, so that is about, what is that? Quantum numbers. After that, shape of orbital. Shape of orbital. Orbitals. What is that orbitals? S, comma, P, comma, D, comma, F. F we don't want to see because F is a disturbed structure. Till now not it is having the fine structure. So we will see the structure of SPDF. S means we know that only one box is there according to the M magnetic quantum number. So it is having only one, that is in spherical shape, S orbital. This is S orbital. S orbital is having spherical shape. Spherical shape. This is the shape of S orbital. If you take any axis, it is a spherical in shape, x-axis, y-axis, z-axis, means it is non-directional orbital. Non-directional orbital. So, S orbital is in spherical shape. It is non-directional, means wherever you take, it is does not having any particular direction. So, it is non-directional. Come to the P orbital. According to the p orbital, m value, it is having 3 suborbitals. We know that. According to m value, are you remember or not? I don't know. So, p orbital is having 3 suborbitals. These 3 suborbitals, they are calling with the name of degenerate orbitals. Degenerate orbitals. Degenerate orbitals means which are having the equal energy. We should not separate this is more energy, this is less energy. No, equal energy orbital. Okay. So, to identify these degenerate orbitals, they given the value, the names px, py, pz. And p orbital is having the shape dumbbell shape. Dumbbell shape. Dumbbell, I think you know, we are weightlifting, no, that a dumbbell shape it is. One is first one, x-axis, y-axis, z-axis. X, Y, Z. Another one, X, Y, Z. Wherever it may be, because all are with 90 degrees only. No need to, what is that, specify this. It is only x-axis, not like that. Okay. Px means a dumbbell shape on x-axis. Dumbbell shape on x-axis. This is Px. Py means a dumbbell shape on y-axis. Dumbbell shape on y-axis. That is Py. Pz means a Pz. Dumbbell shape on z-axis. Right. Very good. Dumbbell shape on z-axis. That is Pz. This is the structure. So, it is particularly on the axis. So, these are directional orbitals. Directional. These are having particular direction. So, directional orbitals. I hope you understand. Copy this. After that, we will go for d orbital. D orbital. D orbital, we know that a d orbital is having 5 degenerate orbitals, 5 suborbitals are there. These are called as again degenerate orbitals. For f orbital, if you take how many degenerate? Only one orbital. That too non-directional orbital. 5 degenerate orbitals. For this, they given name dxy, dyz, dzx, dx square y square, dz square. Don't get confused. This is dx square y square. Here there is no z. And the shape of d orbital is a double dumbbell. Double dumbbell. Now, x, y. For our convenience, I am writing only 2 axes. Whatever you want, you can write x, y. Means, what is the meaning? dz also there, but I am not writing. yz, zx, or xz also you can write. xy, xz. Now, if you say 2 dumbbells dxy, I am doing dxy. 2 dumbbells are there between x and y axis. Between the axis, these are. Between the axis, this one. Between the axis. This is a dxy. 2 dumbbells are there between the x-axis and y-axis. Z-axis as usually like this, 3-dimensional only. So, between 2 axes a dumbbell is there, means that is 2x. Where between means between x and y, so dxy. Between y and z, dyz, like this. Right. Between x and z, dxz, dzx also you can write, no problem. Right. After that, dx square y square. This is dx square dx square y square means on the axis. Two dumbbells on dx and y on the axis. Now come to the dz square only on z axis, means two dumbbells like one direction, one is in back direction. So for like this we are indicating. This is also directional orbital. Directional orbital. So this is about the shapes of SPD orbitals. I hope you understand. After that, 3 important principles are there. Number 1, Aufbau principle. Aufbau principle. Based on this only we are writing the electronic configuration. Listen carefully. Electrons enter into lower energy level first. After go for higher energy level. Higher energy level. This one. How? What is the order? 1s is having less energy level. After that 2s. After that 2p. This order is very important to write the electronic configuration. After that 2s, 2p. After that 3s, 3p. After that 4s, 3d. 4s, 3d. After that 4p, 5s. Like this. Why? Here till now you don't have any objection. 3s, 3p, this one, sorry. Till now 1s, 2s, okay, 2p, okay, no problem. 1s, 2s, 2p, 3s, 3p. Why 3d is not there? Because here one rule is there according to Aufbau principle, n plus l rule. N plus l rule. If you take 3p, sorry, not 3p, 3d, 4s, n plus l, what is the n value? 3. D value for L value for D orbital 2 0 1 2, yeah, is equals to 5, right. 4, S value 0 equal to 4. According to n plus L rule, which has more n plus L, that has more energy. I think, are you understand? In 3D and 4S, which is having more energy? Obviously 3D. So that after 4S we are getting 3D because 4S is having less energy. Now come to the 3D and 4P. 3D and 4P. 3 plus 2 is equals to 5, right. 4 plus for p orbital 1 only, no, 5. Both are having same only, no. But according to this rule, which is having the more n plus l value, that is having the more energy. But here both are same only. Here we need to consider n value. If it is same, which is same, n plus l value is same, which has more n value, which has more n value, that has more energy, I hope you understand. Now in this is more energy, in this is more energy. This is Aufbau principle. You know that every s orbital means 2 electrons. P means 6 electrons, maximum number of electrons. D means 10 electrons. F means 14 electrons. 14 electrons. This order you need to remember. This order is enough. More than this we are not going to get here. So this order is you have to remember to write the electronic configuration. Remind it again. We are going to the electronic configuration. There we need to discuss this one. Is it clear? Hund's rule. Second principle is Hund's rule. Hund's rule means we already discussed this one. First we will go for, I already told you, if you write 2p4 means you should not write like this. What is the reason? Reason is according to Hund's rule, in orbitals, filling of electrons takes place by completing half fill. Then they go for pair up. So first, if you want to write 4p4 means you have to write 1, 2, 3. After half filling, then only they go for pairing up. I hope you understand. This is Hund's rule. After that, Pauli's exclusive principle. In this principle, this is based on 4 quantum numbers. 4 set of quantum numbers, N, L, M, S. These 4 set of quantum numbers is not equal for any 2 electrons. Any 2 electrons, if you take 3s1 and 3s2, if you take, for example, for 3s1 this is, for 3s2 I will write here N, L, M, S, no problem. For N value 3, okay. L value for S orbital 0, okay. M value S orbital 0, okay. First electron, so plus half, okay. For here N3, L value 0, M value 0. For second electron, so plus half. If, sorry, minus half. For second electron, no, so minus half. So any 2 electrons if you take, at least any one of these 4 quantum numbers, one is different from each other. So 4 set of quantum numbers not equal for any 2 electrons. What is that? 4 set of quantum numbers not equal for any 2 electrons. That is Pauli's principle. So if you take any 3 may be equal, 1 is not at all equal. If here it is yes or spin quantum number is different. If you take another electron example, maybe in these 3 anything may be not equal. So 4 set of quantum number is not equal for any 2 electrons. Last topic in this electronic configuration. I already given that order when we are teaching above principle. 1s, after 2s, 3s, 2p, 3s, 3p, 4s, 3d. 4s, 3d. If you want to write electronic configuration, I already given that S orbital can accommodate maximum 2 electrons, means it can accommodate even 1 electron also. P orbital 6 electron, maximum means up to 6 it can accommodate, below 6 also it can. D orbital 10 electrons, F orbital 14 electrons. 14 electrons. Now, if you take for example, aluminium 13, number of electrons I already explained you, number of electrons equals to atomic number, so 13. How to arrange the electrons in this orbital? 1s, first 1s, first they will go for lower energy level according to above principle, after that higher energy. After filling this, then they will, after filling this, then they will go for this, after filling this, then they will go. Like that, 1s, how many electrons it can accommodate? Maximum 2 electrons. It is available 13 electrons to 2 electrons. After filling 1s, they go for 2s. 2s maximum 2 electrons. 4 electrons over, still 9 electrons are remaining. After that 2p. 2p maximum electrons 6. How many over? 10 electrons over, still 3 electrons are there. After filling 2p, they go for 3s. 3s maximum 2. 12 electrons over, 1 electron go for 3 people. This is the way to write electronic configuration. For example, last manganese 25 atomic number. So number of electrons also 25. First 1s2, 2s2, 2p6, then they go for 3s2, then they go for 3p6. After 4s2, how many over? 2 to 4, 6, 10, 20 over. Still 5 electrons remaining. 3d can accommodate, d can accommodate 10 electrons. So we required only 5, 3d 5. That is the way to write the electronic configuration.